Before we start our lesson for today, I am inviting you to join us in a magical learning experience at home. Enroll now in Vibal's Happy Homeschool program. You can find the details in the description of this video. Hope to see you there! In the field of chemistry, this is one of the most important references. It is an organized table of known elements. Do you know what that is? Right! It's the periodic table of elements. In today's lesson, we are going to learn more about it. Come on, let's begin! Hi everyone! Welcome to another episode of our Scientific Friday. I am Teacher Janelle and I'm on a journey again to understand the different things around us. Are you ready to join me for today's lesson? Come on! The periodic table is one of the most important tools in the history of chemistry. It organizes a lot of information about all known elements. What do you think will happen if the periodic table was not developed? If the periodic table was not developed, chemistry will all the more become difficult for us to understand. We will have difficulty in finding information about elements. In the end, it will be a total mess. For today's lesson, we will explore the periodic table of elements. In this topic, we will learn about the following. What is a periodic table of elements? How do we read the periodic table? How do we characterize each element in the periodic table? Are you ready to know the answers to these questions? Let's go! Let's have a brief history of the periodic table of elements. In the early years, a Russian chemist and inventor, namely Dmitry Mendeleev, who was considered the father of periodic table, decided to write a modern organic chemistry textbook and tackle the problem of the disordered elements. Putting the elements in any kind of order would prove quite difficult. During this time, less than half of the elements were known, and some of these had been given wrong data. It was like working on a really difficult jigsaw puzzle with only half of the pieces and with some of the pieces deformed. So, to lessen the difficulty of understanding the elements, he arranged them according to both atomic weight and valence. Not only did he leave space for elements not yet discovered, but he also predicted the properties of 5 of these elements and their compounds. Eventually, his new periodic system was published in the German chemistry periodical Journal of Chemistry. We now know the brief history of periodic table. Let us know more about it. A periodic table is organized like a big grid. Each element is placed in a specific location because of its atomic structure. As with any grid, the periodic table has rows from left to right and columns from up and down. Each row and column have specific characteristics. In the periodic table of elements, there are 7 horizontal rows of elements called periods. The vertical columns of elements are called groups or families. The most common way the periodic table is classified is by metals, nonmetals, and metalloids. In each period horizontal row, the atomic numbers increase from left to right. The periods are numbered 1 through 7 on the left side of the table. Elements that are in the same period have chemical properties that are not all that similar. Take for example sodium and magnesium, which both belong to period 3. In reactions, they both tend to lose electrons. After all, they are metals. But sodium loses 1 electron while magnesium loses 2. Chlorine, down near the end of the period, tends to gain an electron, and it's a non-metal. Now you know about periods going left to right. The periodic table also has a special name for its vertical columns. Each column is called a group or family. The elements in each group have the same number of electrons in the outer orbital. Those outer electrons are also called valence electrons. They are the electrons involved in chemical bonds with other elements. The families are labeled at the top of the columns in one or two ways. The older method uses Roman numerals and letters. Many chemists still prefer and use this method, and the newer method uses numbers 1 through 18. For example, nitrogen has the atomic number 7. The atomic number tells you that there are 7 electrons in a neutral atom of nitrogen. How many electrons are in its outer orbital? Nitrogen is in the 15th column labeled group VA. The V is the Roman numeral for 5 and represents the number of electrons in the outer orbital. All the information tells you that there are 2 electrons in the first orbital and 5 electrons in the second. Now let's discuss the important families that are given special names together with their characteristics. Alkali metals. Alkali metals make up group 1 of the table and comprise lithium through francium. They have very similar behaviors and characteristics. Hydrogen is group 1, but exhibits few characteristics of metal and is often categorized with the non-metals. Alkaline earth metals. The alkaline earth metals make up group 2 of the periodic table from beryllium to radium. The alkaline earth metals have very high melting points and oxides that have basic alkaline solutions. Their characteristics are well described and consistent down the group. Transition metals. The transition elements are metals that have a partially filled subshell and comprise groups 3 through 12 and the lanthanides and actinides. Post-transition metals. The post-transition elements are aluminum, gallium, indium, thallium, tin, lead, and bismuth. As their name implies, they have some of the characteristics of the transition elements. They tend to be softer and conduct more poorly than the transition metals. Metalloid or semi-metal or poor metal. The metalloids are boron, silicon, germanium, arsenic, antimony, tellurium, and polonium. They sometimes behave as semiconductors rather than as conductors. Lanthanides. The lanthanides comprise element 57 or lanthanum, hence the name of the set, until the element 71. They are grouped together because they have similar chemical properties. They, along with the actinides, are often called the F elements because they have valence electrons in the F shell. Actinides. The actinides comprise elements 89 through 103. As I mentioned earlier, the actinides and lanthanides are often called as the F elements because they have valence electrons in the F shell. Only thorium and uranium are naturally occurring actinides with significant abundance. They are all radioactive. Non-metals. The term non-metals is used to classify the elements hydrogen, carbon, nitrogen, phosphorus, oxygen, sulfur, and selenium. Halogens. The halogen elements are a subset of the non-metals. They comprise group 17 of the periodic table from fluorine through astatine. They are generally very chemically reactive and are present in the environment as compounds rather than as pure elements. Noble gases. Noble gases comprise group 18. They are generally very stable chemically and exhibit similar characteristics of being colorless and odorless. Now that we know the important details about the periodic table, let us now try to know how to read it. When you look at a certain element in the periodic table, you will find some basic information about that element beside it. Let us start with atomic number. It is the number of protons in an atom and it defines what element it is. For example, carbon atoms have 6 protons, hydrogen atoms have 1, and oxygen atoms have 8. The number of protons in an atom is referred to as the atomic number of that element. The number of protons in an atom also determines the chemical behavior of the element. The atomic symbol is 1 or 2 letters chosen to represent an element, H for hydrogen, for example. These symbols are used internationally. Typically, a symbol is the truncated name of the element or the truncated Latin name of the element. The atomic mass or weight is the average mass of an element in atomic mass units or AMU. Though individual atoms always have an integer number of AMUs, the atomic mass on the periodic table is stated as a decimal number because it is an average of the various isotopes of an element. Lastly, the electron configuration is the orbital description of the locations of the electrons in an unexcited atom. Using principles of physics, chemists can now predict how atoms will react based upon the electron configuration. They can predict properties such as stability, boiling point, and conductivity. We know that we also gain information from the periodic table by looking at how it is put together. By examining an element's position on the periodic table, one can infer the electron configuration. The periodic table contains an enormous amount of important information. People familiar with how the table is put together can quickly determine a significant amount of information about an element even if they have never even heard of it. Before we end our lesson for today, I am inviting you again to join us in a magical learning experience at home. Enroll now at Vibal's Happy Homeschool program. You can find the details in the description of this video. And that's it for our discussion today. I hope you learned a lot and apply these learnings in your daily lives. Join me again for our next Scientific Friday, and together, let us discover things around us. Because science is everywhere. This has been Teacher Janelle for Teacher Vibal. Goodbye, everyone!